Welcome to the content material for Class 18 of Engineering Statics. You should be watching this video before your 18th class. In this lesson, we will learn what is a machine and how to determine forces in its members. Last class, we looked at frames. Today, we will learn how to analyze machines. A machine is a group of members connected by pins with moving parts that are used to transmit and alter the effects of forces. Pliers, pulleys, and this backhoe are all examples of machines. Analyzing a machine is the same as analyzing a frame. We first isolate the individual parts of the machine. In this example, we can isolate 3 parts of this machine. Then we identify the forces acting on each member, as shown here, and any internal forces between members are equal and opposite. Many times, a machine contains pulleys. To analyze a pulley, we separate each wheel. So, for this example, this pulley system has 3 pulley wheels. If we draw a free body diagram for each pulley, it would look like this. The important thing to remember about pulleys and cables is that the tension force in the cable is equal all the way through the cable. So each time we label, we should not give it different labels. And so this cable runs all the way through here, and so that force, which we label here as P, is equal at each point in our separate free body diagrams. So let's look at some examples of how to solve for a machine. So in this example, we have a 500 kilogram elevator, and it's being lifted up by a set of pulleys. And there's actually 2 different cables here. And we're going to neglect the weight of the cables and the pulleys, and we're going to try to figure out what is the force developed in each of those 2 cables as it pulls up this elevator. So the first thing we're going to do is we're going to separate it into 2 different parts. So first I'm going to draw the elevator itself, which has a weight, and it has these 2 pulleys attached to it. And we know that this is the first cable on this pulley, and this is a second cable. So I'll just call that T1 and T2. And finally, that first cable is also pulling up here in the middle of the elevator. At the same time, there's a pulley C, which is connected to that first cable. So again, remember that the tension force in the cable is always equal, and this is that second cable. So there's only 2 cables, so there's only 2 different forces, T1 and T2, that we're trying to solve for. So the first thing we're going to do is we're going to look at pulley C over here. And if we sum the forces in the y direction according to pulley C, we can see that T2 minus 2 T1 is equal to 0. In other words, T2 is equal to 2 times T1. Now, if we look at the elevator and we sum the forces in the y direction for that, we see that there are 3 T1s and 2 T2s pulling up and a weight down. So we're going to write that out. We'll say 2 T2s, 3 T1s, and the weight is pulling downward. So 2 T2 plus 3 T1 . And so now I can put those 2 equations together and solve. And we find that this is 1,400. So a simple example But the idea here is that we want to understand that the tension in a cable for a pulley is always equal throughout the length of the cable, and so we can use that to simplify the problem and solve it. In this example, we have both a frame and a pulley together. So again, what we need to do is we need to separate each of the individual parts. And so if I do that, it would look something like this. First we have member CB. This is a two-force member, so we want to draw that. We know the direction, and we call that force BC. I'm guessing that it's acting in tension. We also have member ABD, and so the equal and opposite force of BC is pulling there at point B. And we have the reaction at pin A, so it has both a Y and an X component. And we also have the reaction at pulley D. So I'll draw pulley D first. So there's the tension in the cable, which is equal on both sides. And there's the connection at pin D. So if I draw it this way, then I draw the opposite here. This is the reaction back from the pin D on the pulley. And finally we can draw the cylinder, which has a weight and the tension. So we'll break this down, starting with the easiest part. First thing we want to do is we want to start with the cylinder. Very simple. T is equal to the weight. That's a 50 kilogram mass. So we see that T is equal to 490.5 newtons. Now we can move on to the pulley. Here we're going to start by summing the forces in the x direction. So the pulley has the tension, which we know, and we can use that to solve for dx. So dx is equal to the tension, which we already know. We can now solve in the y direction. Same thing. dy is also equal to the tension. Next we'll move on to member AD. So member AD has several forces on it, but we've already solved for dx and dy. So if we choose the point A and do the moment about it, it allows us to ignore the reaction at pin A, and we can solve for the force BC. When we solve for force BC, find it's 245.3 newtons. And next we can take the sum of the forces about the y direction for member AD. And we see that there are two forces, dy and ay. And finally we can sum the forces in the x direction. And find that AX is 735.8 newtons, And so now we have what we needed. We wanted to know the reactions at pin A, we wanted to know the reaction at pin C, and we have that information. And we know that the Y component for C is 0 because member BC was a two-force member, and because of the direction of member BC, we knew that the force was directed along the x-axis. There we go.